Hello, my name is Ryan Gatos, and this is my ME5431 final product presentation. Today I'll be presenting on safety of manufacturing systems with industrial robots and human workers, how automation reduces risks and protects workers. Slide 2, Introduction. Today I'll be discussing how the integration of robotics in manufacturing processes impacts worker safety. The agenda for today's presentation includes a discussion of the role of robotics in modern manufacturing process, identification of common safety hazards in manufacturing, a discussion of a case study regarding the impacts of robots and automation on health and safety outcomes of workers in small manufacturing enterprises. Lastly, a discussion on future developments regarding the implementation of robotics in the manufacturing process and their effects on worker safety by discussing cobots. So slide 3, the role of robots in the modern manufacturing process. The integration of robots in manufacturing has increased in recent years, with robots performing a wide range of tasks from assembly to quality control. Robots enhance efficiency and precision in the manufacturing process, leading to higher productivity and lower error rates. Robots are typically used in automated production lines for tasks such as welding, cutting, machining, and packaging. Slide 4, common safety hazards in manufacturing. In 2020, there were 373,000 total non-fatal injuries in the United States manufacturing sector. So that corresponds to an incident rate of 3.1 for every 100 full-time workers. The most common manufacturing sector workplace injuries included sprains, strains, tears, and fractures, with events which are the leading cause of injury, including exposure to harmful environments, being struck by an object or equipment, falls, being caught in machinery, and general overexertion. Slide 5, how robots improve safety. Industrial robots perform physically intensive tasks, reducing the risk of health issues and accident rates. Benefits include reducing musculoskeletal disorders caused by repetitive or awkward motions, preventing traumatic injuries like cuts and lacerations, and mitigating risks in emergency situations. One such example would be during a chemical spill. Slide 6, transitioning now into a discussion of a case study which detailed the effects of implementation of automation and robotic systems on worker safety. So this particular study was conducted by the National Institute for Occupational Safety and Health and evaluated automation's impact on workplace safety. This particular study was focused on 63 small manufacturing enterprises and utilized a semi-quantitative tool based on the 1995 Occupational Health and Safety Administration draft tool to calculate the musculoskeletal disorders risk factor. And so what played a part in determining this risk factor was awkward poses, repetitive motions, and manual materials handlings. These risk factors were defined as a Z-score, which is a measure of the number of standard deviations a data set is from the mean, and pre and post implementation of these robotic system scores were calculated to determine the overall risk reduction to the workers. Slide 7, key findings from the case study. The first key finding is that they determined that the implementation of robotics in the manufacturing process led to a reduction in musculoskeletal injuries, An example from the case study was found that robotic arm pick-and-place tasks in snack feed manufacturing reduced repetitive motion injuries and MSD risk factors. They determined that there was a decrease in injury claims, with employers reporting up to a 50% reduction in workers' compensation claims post-implementation of robotic systems. They also determined that the implementation of robotics into the manufacturing process led to productivity gains. They found that productivity increased from anywhere from 10 to 30% in workplaces that implemented automation. So just to summarize the major findings from the case study, they determined that the implementation of robotics had a positive impact on health outcomes and workplace safety, reducing physical strain of workers in the plant and improving safety measures for workers in general. Slide 8. I'd like to transition and discuss future developments in robotics which will lead to safer workplaces. The topic which I'll be discussing is cobots. So collaborative robots, again, commonly referred to as cobots, are designed to work safely alongside humans with advanced sensors and easy programmability for flexible tasks, such as assisting workers in assembling sensitive electronic components. In contrast, traditional robots operate in isolated areas, usually with protective fencing or structure around them, and are intended to perform high-speed, high-powered repetitive tasks with less adaptability and programmability for flexible tasks. Advantages of cobots include reducing physical and cognitive loading on workers and provide controlled assistance, reducing the likelihood of injuries from repetitive motion to the worker themselves. Slide 9, industry application of cobots in the manufacturing process. So while still a generally new concept, there have been a few studies regarding the implementation of cobots into industry. One such example would be General Motors and Ford partnering with Northwestern University and UC Berkeley to develop and test cobots. And so based on ongoing tests, they found that cobots contributed to a 32% reduction in cases involving days away from work due to overexertion or repetitive motions, and the incorporation of cobots has resulted in improved efficiency and reduced error rates in the assembly lines. And so in short, cobots represent a significant advancement in industrial automation, providing a safer and more efficient working environment. Slide 10, the cobot safety features. So what makes a cobot safer than a traditional robot? Cobots have several key features which allow workers to be in close proximity to and collaborate with the robot during the manufacturing process, including speed limitations and separation monitoring, which cause the robot to slow down when a worker comes near. Safety rated monitored stop, which stops the robot when a worker enters a collaborative workspace. Hand guiding, in which the worker is in direct contact with the robot, guiding and training the robot, but the actual force doing the work is being applied by the robot itself. And lastly, there's force limiting, which causes the robot to stop when it contacts a worker or any other object before injury or damage can occur. So slide 11, conclusions and takeaways from today's presentation. We determined that robots play a major role in the modern manufacturing process, performing a wide range of tasks. The integration of robotics into the manufacturing process reduces the rates that workers are injured, as robots are able to perform repetitive and awkward motions, which are the leading causes of workplace injury. And further development and implementation of advanced technologies such as cobots will continue to increase safety and productivity in the manufacturing process. So lastly, slide 12 references. These are the references which were used in today's presentation, and I'll make these available in the description down below if anyone is interested in reading the source articles themselves.